Hello, everyone. Oh, sorry. Hello, everyone. Welcome back to SAT Math Question of the Day, where we do one question a day. Here's our question. Please pause. Please try it. Pause the video. Come back, and we'll do it. If the fraction x minus 3 divided by 7 is equal to x minus 3 divided by 9, the value of x minus 3 is between which of the following pairs of values? Wow, we haven't seen a question like this in a while where it's weird, where you'll never get a question like this in school. Like, what do you even do to this thing?
You notice
Yeah.
that this equation is true only if x minus 3 is 0. And therefore, x minus 3 is 0 if it's true. And 0, and the only choice for 0 is that it's between that fits zeros is b, between minus 1 and 1.
The value of x.
The solution, you solve for x.
Yeah.
Well, it's easier to just solve for x minus 3.
Right. X minus 3 is equal to 0. So x is equal to 3.
No, it asks.
The value of x minus 3. The value of x minus 3 is between, I see, x minus 3 is equal to 0.
Yeah.
So that means the only number that x minus 3 can be between is b. Yeah. Wow, you have to actually have some intelligence here to do this problem. This is not a straight arrow problem. This is classic SAT, and we've heard rumors that the digital SAT has even more questions like this.
Yeah.
Wow, this is where Seth's background in math comes in very, very handy. I didn't have a chance to try it because you did it, which is fine. Wow, I don't know what I would have. Maybe I would have multiplied 9x minus 3 is equal to 7x minus 3. Well, I mean, I could have done that, couldn't I? And this is 9x minus 27.
No. Well, the point is, it's a matter of sensitivity to the patterns.
Yeah.
So there's a thing that to notice that x minus the numerators are the same, and the denominators are different.
Yes. The pattern saves you big time.
And so what happens is a same number is multiplied by one number, and the same number is multiplied by another number. And the only way the results could be equal is when there's 0.
Okay, let's say you don't have... Seth has a PhD in math. I only have a PhD in mechanical engineering. Let's say you don't have a PhD in math, and you don't see the pattern. Okay? Like, maybe I wouldn't have seen that pattern. So I could have done it the regular straight way and still gotten the same answer. It would have taken maybe 25 seconds longer. I could have just done it the straight way. You cross multiply, you solve for x. X is 3. So x, now they got to be really careful here. If x is 3, then x minus 3 is equal to 0, and I get the same answer, and it took me 25 seconds. And I didn't have to get a PhD in math. Yes. Looking for patterns is the way to solve these problems faster. But you didn't necessarily have to find the pattern. You could have done it just straight arrow way and still got the same answer. It's just would have taken you 25 more seconds.
The lesson here is for people, if you want to get a better score on the SAT, take this video to show you what other things in math to look for.
Yes.
and
Yes.
develop a greater sense of sensitivity and perception in math contexts.
Okay.
Go beyond the recipes that the teacher teaches.
I'm into recipes. But
I'm
yes.
into I'm into I'm into I'm into I'm into I'm into mixing, cooking, smelling, tasting, and eating and enjoying the deliciousness of a variety of healthy foods.
Yes. I totally agree with you. The thing is, it takes brain power to realize patterns, and you use it by using up every time you have to think, even outside the box. It uses up some brain skills on the test.
No, the more braining you do, the stronger your brain gets.
Not during a performance sport, which is not during the SAT. Yes, training and studying, absolutely. But if you're running, you want to run in the most efficient, the lowest energy way.
Yes, you do. But what we're doing for you now is talking through how to prepare for the SAT.
Yes, that is true. Seth, you're absolutely right. So I'm going to
Yeah,
add.
I'm just arguing today
No. You're arguing well.
because the thing is, when I see something really elegant, just beautifully directly, beautifully, simply, succinctly. And then I see someone hobbling, it makes me feel very uncomfortable.
I can see that. You don't look very comfortable when I'm talking about the way I'm doing it. You look
That's right.
very upset. Very upset.
Very upset.
Very
Yeah.
upset. Very upset. So what the one we will do is we'll add another question to our questions. I'm going to write it down. Excuse me over here. Patterns. Is there a pattern in the question at hand that you could take advantage of to save you time and to do the problem more elegantly? Okay? Because a lot of these problems do have patterns. Patterns are a key word in the SAT, and probably when they go going
What
digital,
is okay? That's
it's gonna be
fine.
even more
So
of a pattern.
let's let me circle the pattern. I already did it.
Yeah,
Here's
you
the
already did
pattern.
it. You already did it. You already did
This
it.
is the pattern. This is the pattern.
Yeah, cookie over 9 is cookie over
And
7.
in general, A multiplied by let's call it C
Yeah.
equals B multiplied by C, where A is not equal to B. And this could also be A, B, C, E inverse multiplied by C equals F
Stop
inverse multiplied by C, which is equivalent to C divided by E equals C divided by F.
You've lost everyone. Forget it. You've lost.
That's the pattern. That is the pattern. What? The pattern is this, and when this pattern occurs, the only way for when A is not equal to B, the only way for this to be satisfied is when C equals 0.
Right. Now, if you want to show it another way, which maybe some people would like to see, we could take this equation and we can move everything to one side. So we go dog times 3 minus dog times 9 is equal to 0. We do what's called the greatest common factor, which is, you'll see, this will actually work out quite nicely. We do dog, and then 3 minus 9 is equal to 0. Now, the only way, this is a negative 6. Dog times negative 6 is equal to 0. So the only thing dog can be is 0. So if this isn't obvious to someone, then this is the way to show it. Another way to show it. Sometimes it's
Okay.
good.
Well, what's fundamentally happening, which you didn't learn because they don't teach this in mechanical engineering,
Yeah, I know. Okay, I think sure
is
they don't
that
teach a lot of stuff.
is that for ordinary numbers, if A times B equals 0,
Yeah.
one or both of A and B must be 0.
Okay. Yeah, that's called isn't that called the multiplicative property of 0 or something?
Uh,
There's a name for it.
what's it called?
Well, whatever. It doesn't
It,
matter what it's
it
called. It doesn't
means
matter what it's called.
there's a fancy name for it in mathematics, and it's the property of a ring to be a domain. If
Okay.
you want words for it, the kinds of words that you do learn when you get a PhD in mathematics, what people are taught when they get PhDs in mathematics is that this property
Right. Or both.
this property is called the property of a ring
Right.
being a domain.
Okay.
This is called the domain property. So that's the name for it.
Yeah, okay, this
But
is PhD
but it's something that for being really perceptive on SATs, it's a property of ordinary numbers that is very useful to be aware of.
Yes, absolutely. Of course. Nobody doubts that it's very useful to be aware.
Yeah.
Okay, so there are at least two ways to do this problem. There are other algebraic manipulations that you can make, which I don't know if we want to. But I guess we could try this one, just to show that what you can do, because it does show another way of doing it, which Seth may actually like. You could do x minus 3 as a package times 9 is equal to 7 times x minus 3. You bring everybody together. You do x minus 3 times 9 minus 7x minus 3 is equal to 0. You factor out the x minus 3 and you get 2 is equal to 0, so you see x minus 3 has to equal 0.
That's great. Yeah, that demonstrates that the pattern that we observed directly, the pattern that we observed that I wrote in red, is a consequence of the A times B equals 0 means one of A or B or both is 0.
Right. Exactly.
Yeah,
now,
that's how it follows.
I don't know if a lot of people will be doing this because this is temptation to distribute as opposed to keep things as packages. This happens to be
well, the thing is, in graduate mathematics, even undergraduate math, a ring is a system where there's addition and multiplication, and among other things, the distributive law holds.
Okay. Forget the ring.
Ring, yeah.
Forget the ring, because nobody's in third year math in college. Everyone's trying to get into college. So forget the ring.
They barely. It's very rare that they would teach the word ring in high school.
I know. That's why we should drop the ring and move on. Okay.
Yeah, I'll show you. Here's my ring.
No. Okay, there's the ring. Right. We each have rings. It's very nice. We each have rings. Okay. Yeah. So I guess we should move on. Oh, today's Throwback Thursday. So we have a throwback. Yeah. Oh, no.
Well, let me say one other thing is a main idea in this problem.
Yeah.
The main idea, another main idea, is that if you have you have something in algebra, And within the equation or within the expression in algebra, there are two identical subexpressions. Two subexpressions that read exactly the same.
Mm-hmm.
Then the principle is that the expressions that read exactly the same denote the same values.
Okay.
I said, don't listen, that expressions that are the same,
Okay.
they, in the same sentence, they mean the same thing.
Okay. Okay.
So in say if you have an algebra question like 3x plus 4 equals 2x plus 9.
Yeah.
The x's on the left-hand side and the right-hand side are names for the same unknown number.
Okay. I'm doing something.
That's the only way it makes sense to solve for x.
Okay.
And in SAT level algebra, it's common for you to be given equations and to be given expressions where letter X appears in multiple places.
Okay.
And it may be obvious, but it's critical in the thinking mode of math, is that the X stands for an unknown quantity.
Yeah.
But repetitions of X in the same expression all stand for the same unknown quantity.
Right. Okay.
And so a generalization of that is that identical expressions stand for the same thing. So an extension or generalization of what I just said is, for example, 3 times x minus 3 plus 4 equals 2 times x minus 3 plus 9. The x minus 3's these two x minus 3's stand for the same numbers.
Okay. I think let's move on. Okay, let's move on. I'm sorry I wasn't paying attention before. I'm doing something everybody does. I wasn't paying attention because I was doing something else with the computer. Today's Throwback Thursday, and I forgot to load the question onto the board we use. So I was actually, if people saw I was not paying attention, I wasn't paying attention. Very bad habit, very bad modeling. Okay, let's move on to the next 4. Let's move on to our questions. Calculator section, not really. Calculator doesn't really help here. Do you start with the guesses? Probably not. Is this different from how would you do this question differently than if it was on a school test? Well, you wouldn't get this question on a school test. New question. Is there a pattern that helps you solve this question faster than the straight arrow approach? Absolutely. We spent a lot of time on that. The main idea. What was the main idea of the test taker person who wrote the team, the committee? who wrote this question, what were they trying to see if you knew what to do? So that's an interesting one, because were they looking purposely to see whether you can note that pattern? I doubt it. But that may have been an ulterior motive of theirs, is to put bait in front of people and say, hey, here's a question that you could solve in a second if you see the pattern. But if you can't, then it's really just solving a proportion. Solving a proportion for x. And also making sure you answer the question, because it's too tempting to solve for x, which is 0, and then you answer...
No, it's 3.
X is 3, right. It's too tempting to solve for x, get x is 3, and answer this. Interesting that they put this directly next to this one. That is dangerous. So that is a dangerous thing to watch. That is, I'm sure more than a few people would make that mistake. So it's reading the question, which is always a common theme of a main idea of the question. And it's really we don't know whether their main point was to set up an algebraic equation of proportion, or do it or purposely do it in a way to give you a pattern.
Well, can you does this body of questions come with an indication of how hard the question is?
I think it does. So should we do that? Should we see that? Okay, so we're done, right?
Yeah, we're done.
Clear all drawings.
Except for Throwback Thursday.
Yeah. So now we're going to go to question 30. This is from what's called the question and answer service. Back when the SAT was not digital, they used to give out the tests to people if you paid a little, of course, if you paid a little extra money. So it's always that way with them. So that would be 30. That was question 30, right? 30. 30 in the calculator section. Maybe they didn't give the difficulty level.
They just give the answers.
Yeah.
All right.
30 is B. Oh, they don't give you the difficulty level. Oh, okay. Yes, they do.
Oh, they are. Okay.
Yeah. 30 difficulty level. Okay. Oh, hard. The hardest. Wow.
Oh, wow. All right.
Yeah, the hardest. Okay.
Yeah.
Okay, so Throwback Thursday. We're having some technical difficulties today with Throwback Thursday, so we're going to have to do Throwback Thursday on Friday, which is fine. We're flexible here.
Should we do our introduction to ourselves?
Yes, we're going to do our introduction to ourselves and bid goodbye to everyone. So I'm Joel. I have a PhD in mechanical engineering. My brother Seth is a PhD in math. We've mentioned that before. And we're here to hopefully give different approaches and share with you some ideas we have on how to do SAT math questions. We have different approaches. We have different ways of doing things, which is good. We try to offer different lenses. And in terms of practicing, take as many practice questions as you can, whatever topics you don't know, you're not sure about, go to Khan Academy Digital Practice. They partner with the SAT. There may be 20, 30 questions per topic. You could study on those and learn from your mistakes. Study and learn from your mistakes, and particularly do what Seth said, which is see if there's more than one way to do the problem when you're studying. And that will give you some depth and strength to approach problems from all different angles as necessary. Okay, that's about it. Please leave comments on our videos. We take all our comments very seriously. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. Everyone, have a great day.
And the email address is printed on the home page of this channel.
Yes. And we'll hope to see you tomorrow, Friday, and we'll do Throwback Thursday tomorrow. Take care, everyone.